Okay, happy Tuesday. Welcome everyone to class. Can everyone on Zoom hear me okay?
Yep.
Yep.
Cool. Sounds good. Awesome. Yeah, so for the next rest of class, we'll just be going over final project stuff during class. One of the classes, though, will take maybe half of the class to look at rendering your final objects, so making a digital render of it. And if we finish in time, then we can definitely also 3D print the projects as well. We just can't wait till the last day to do that, but it is possible. So for today's class, we'll just go through everyone who has updates again. So if anyone has questions, feel free. Whoever wants to start. So.
I have a question.
Yeah.
I have like a cap, but with the diamond pattern, there's like a few edges that don't end in a perfect V.
Yeah.
Is there a way to fix that?
Oh, I see. So what pipe component are you using? Just a normal one?
Yes, just
Okay. That might be why.
okay.
If we do something else, like we could do a pipe method with Dendro, which might just be a little bit easier for you. Like to construct the pipes in Dendro, make it easier for 3D printing and also easier for having this issue not to be a thing. So we can look at that quick. And you're just using the diamond panels?
Yes.
Okay. Cool. So you're using just this pipe, which might give you some issues with the corners. Some of the pipe components have ways to change either the caps or the corners. The one that comes with Grasshopper doesn't. You just have the option to change the ending of it, which isn't gonna do much to help you there. Another tool you could use is the multi-pipe, which comes with Grasshopper. This one will also give you pipes, but it's a little cleaner. It's using the sub-D tools in Rhino, which I've also seen it have problems with corners, but it is an easy one to use if it works. So I'd give that one a shot.
You said that one comes with Grasshopper?
It does if you have Rhino 7 or 8, I believe.
I have Rhino 7, but it's not comparable.
Okay. No multiplayer?
No.
Okay, yeah, the other option, which, I mean, this one's my favorite because it works with anything, is with the Dendro plugin. You have that one, yes? Yeah. So with this one, it's pretty simple. I'm just going to get rid of this. All we need is the actual edges, which the diamond panels, it's giving us surfaces by default. It looks like the pipe thing worked fine when I plugged it in, but one thing we could do just to make it cleaner is there's a brep edges component, which will just give you the edges. So we don't plug surfaces into like a pipe component. That might help a tiny bit. And then what I like to do with Dendro, and this will work with any time you have curves and it should give you really clean ends and corners, is to just use the curve to volume tool with Dendro. Anytime we use Dendro, like we've done before, we always need to create settings to start. And with these settings, the main important thing is just going to be the voxel size, so the S input. And I usually like to do a slider from 0.01 to 1, just because, do you remember back to when we looked at this for the first time, like how the voxel settings work? Or no?
Like maybe.
Yeah, so if we have a larger number like 1, it's going to give us really big voxels, basically like pixels.
Okay.
So it's going to render it really quickly, but if you have massive pixels, then you're not going to see much detail. But if we have a smaller number, we'll see a lot more details. It's just going to take longer to calculate. So I like to do 0.01 to 1 to start and just slide this all the way up to 1 so we can just see the quickest interpretation of this. So we can plug the settings into the S input for the curve to volume. So that'll give us the settings. And then we can just take the edges, which we can probably just take all of the edges. All of these outputs give us different options. It looks like in my case, the only thing that has edges is the naked edge curves output. For yours, it might be more though, because it's also giving us interior and non-manifold edges. But just check, you can hover over the output of the dgraph edges just to see which one actually. Okay, sure. Then we can run that into the curve to volume. So the curve input there. And I don't know about your workflow, but if you have this dotted line, I would flatten it just to make sure it's not a dotted line when it comes in. But yours looks non-dotted to begin with, so that's good. If it is dotted, then it's not going to mesh all the pipes together if you have like different lists of curves. So putting them all in one list is helpful. And the last thing is just to fulfill the radius, which you would do for the pipe component anyway. So you could use whichever slider you have for that. One thing I will note for this is if you plug in a radius that is around the same number as the voxel size, then it's not going to work because we need the voxel size to be lower by 33% in the radius for it to actually render. You could set up some equations to calculate this, so you could multiply your radius by 0.3 and that'll give you a correct settings value, or we could just do it without any math and have two different sliders. So I would just put this setting slider down until you can see the quality is changing as we do this. And then if you already have a radius that you're looking at for a number, then we can go with that and just slide the settings until it looks pretty good. And how's that working? Yeah. Yep, good. Cool, yeah. And then the last thing for this is just right now, it's a volume. It's not like a mesh or BRP or anything, so it's not too helpful for us to export. But you can switch back to a mesh just by using the volume to mesh component. That'll just send this back to a mesh. And again, we need settings for this as well. And you could use the settings that we already have, or you could make a new settings component. It's not going to matter. Just need something plugged in there. But that should give you your final mesh that we can actually bake into Rhino. So yeah, that should work. Yeah, cool. Okay, and how's everything else coming for the helmet? Like the shape looks good and everything?
I think so. I based it off of the mesh that you gave us. Mm-hmm. So I don't know if it would like fit in my head yet, but it fits.
Okay, good. I mean, you can 3D scan yourself or get a friend to do it if you really want to. Okay. Yeah. So that's a great start. So cool. Okay. Who else has questions today? Or on Zoom? Yep.
So we're doing a foam case, we can sort of model the shape of the case first. So what I was planning on doing, I have like a mesh of a foam.
Yeah.
Was going to draw up sort of the rough shape of the case, then do a Boolean subtract to get the foam like out of there. And then from there, I guess take that as a mesh and then start to do fronting.
Yeah. It sounds like it would work. Okay. Like it depends what pattern you want to put on the case, I guess. Like if you're mapping curves around whatever shape you make, just know that if you have a curve on the surface, then if you add radius, it's gonna like go into the foam more. If you get what I'm saying. But like up to you, however you define what you're putting on the surface. But that sounds like it would work. Okay. It worked pretty well, yeah. Was your idea in the chat from last week?
No, because I had asked you after last class. I sort of typed it in.
Gotcha. Yeah, cool.
Been looking at different patterns and stuff.
Nice, nice. Okay, cool. Anyone on Zoom have any questions?
Hey, RJ, I do. Okay. Sorry, I meant to get back to you yesterday and
No
kind of
worries.
got behind on some things, but I'm gonna post. Okay, this is kind of like my inspiration.
Nice, cool.
Yeah, I'm
Yeah.
thinking kind of like South Indian inspired. Like these earrings are like in the top right corner. They're called jhumkas. They're very traditional. And then it's also super traditional to have like jasmine flowers in your hair.
Hmm.
Um, and I kind of wanted to do some sort of spin on like a headpiece that maybe comes down into like those big earrings, sort of like the picture in the bottom right corner.
Okay.
Um, I could use any and all suggestions that you might
Okay.
have.
This is fun. Yeah, yeah.
Okay.
What do you want to start with, like the headpiece or the earrings?
I think the headpiece, my thought with the earrings is that like once you get that one general shape down, like you could just kind of make them smaller, right? And if I were to
Mhm.
print it, I could attach it in some way. The headpiece is where I'm a little more unsure about. Um,
Hmm. Are you thinking more like this from the bottom right? Because you could, I mean, you could print flexible, or you could print some kind of chainmail type thing, so it's PLA but still flexible.
really?
Yeah, let me pull up a photo. Uh, Stop. Okay. Let me see.
What browser is this?
Opera.
Mhm.
Yeah, I like it. Yeah,
Oh,
so
okay, that'd be
you could do anything like this.
ooh, okay.
And they can just be basic shapes too, so you could just do a lot of cylinders in a grid type of array.
Mhm.
Or I've done this like H pattern before. That works pretty well because it's all like straight lines, so you can easily print the bridges.
Mhm.
Um, or, I mean, yeah, you could do something like this where the surface is nice and flat, but the actual chain is below it.
Okay.
Yeah, I mean, there's a lot of options, and designing any of these is basically just designing the singular shape and then
Yeah.
how it's arrayed together. So if you're doing something like this, then you're rotating by like 120 degrees and adding more. But if you do something like one of these, then you're just designing that single piece and then just arraying it out.
Mhm. Okay.
Yeah, so that wouldn't be too difficult. Or I don't know if you've seen this Instagram page. It's always doing this to me. But she uses flexible filament a lot to make patterns.
Ooh, okay. Wait,
Um,
that's really cool.
yeah, so printed on Instagram has some good stuff. I know recently she's been doing like printing flexible pieces that she can then not sew together, but they're like smaller swatches like this that have little hooks and tabs in them, so you can assemble it, which was kind of fun. I don't know if there's photos on. I don't know why Instagram's not working for me, but if you look it up, it should be on there.
I just pulled up her Instagram to see what you're talking about.
Okay.
Ooh, okay. And then any tips for that earring shape, like that bell shape kind of?
Yeah, I mean, so the shape itself wouldn't be, or like the array itself wouldn't be the hardest thing to make. Let's see. Here's my really, really bad file. Because with this, let's see. Because all you'd need to do for the array would be to move and scale it. Should not be too difficult.
And then I could figure out some way to add like an interesting texture or pattern to it.
Yeah, I think the pattern would be the thing that would be more interesting
Yeah.
or difficult, I guess, for this design. Let's see, because this should be a very, very easy setup. Yeah, the only thing that's unique with this would be to like it's getting smaller at the same time, so you couldn't just do a standard. Like you could do a standard linear array, but that would equally space all the points out. I mean, it's a good start, and then we could come back to like figuring out how to make it non-uniform, so like
Yeah.
it also gets smaller.
Yeah, like decreasing. Okay.
Yeah. Let's see. I just want to see how possible this is. So if you started a scale of 1, and then the step size could be like negative 0.1, and we count 10 times. That is not negative 0.1. Yeah, I mean, it would work. I'm just setting it up wrong.
Oh, nice.
Yeah, I mean,
Yeah.
definitely doable, just not uniform. So yeah, we can come back around to that, but let's see the pattern itself. And which one for the pattern were you looking for the most?
Probably something like that top right image. I like how each of those, I don't know what to call them, bells, I guess. Bells has like a bit of like a conical like cylindrical pattern going up.
Yeah.
Yeah, it's kind of hard to see, but yeah, I
Would
guess
you
I
want them all? What was that?
what was that?
Would you want them all to be the same size and pattern? Because it looks like with this one, the one at the bottom only has maybe 2 layers to the bell, but the one at the top has like 4 or 5 different layers.
Yeah, I think they would all, I guess like the top one would have more layers. It would decrease the size for each one.
Yeah, I mean, some pattern like this, I mean, it looks like it's just a lot, many different polar arrays with different patterns. Like, let's see, where to go?
Here, let me try to give you a bit more higher quality image.
Okay, yeah, if you have one.
Yeah. Sorry, that one's like so grainy. Pull it up. Yeah. Maybe that's better.
Okay. Oh, yeah, there you go. Okay. Yeah, so I mean, this one I'm seeing like it has this like halo shape, and then maybe these rings, and then just another kind of geometry arrayed around in a circle, which would be pretty easy to set up. Like you could model some kind of geometry in Rhino, and then like let me see if I copy this and Rotate it a little bit. Maybe scale it down, and then we could start to do the same thing again, just with this one, and then if we add more numbers to it, we can make it a little more interesting. So then like that, we can probably start to quickly build up
Yeah.
kind of shape. Like you could see it could start like getting towards a bell shape. I just keep doing this. Yeah, and I mean the geometry is up to you for what the different levels are. But that's what
Right, right.
I recommend
Okay.
for starting out. Yeah. And then once you have something like this, we can really easily use the first method I did with Dendro and kind of just pull them all together into a single shape. We can mesh them, and then once they're all a single mesh, we should be able to print it. So
Okay.
yeah, that's what I would recommend.
Awesome. This is so helpful.
Good, good. Yeah, I'm glad that these will probably be easy to print. The headdress chain might be the most difficult thing to print, but probably pretty easy to design once you figure out like what the geometry is for that. But the chainmail is pretty fun.
Okay. Well, thank you.
Oh, yeah, you're welcome. Okay, anyone in class have some questions?
I did my main body and sculpted it in Blender. I'm not sure what to do next.
Okay, Blender works. Do you want to come look at it? Yeah. Oh, okay. Yeah, no, that's looking like that. Pretty good.
I'm not sure how to import it into right
Yeah, I guess the question is, do you want to add some kind of pattern slash texture to it in
Yeah,
Rhino
like-
Grasshopper? Okay, what are you thinking about for that?
Probably just lines going up, or maybe something that's dots or dots.
Yeah.
Going up.
Okay. Yeah, the easiest way I would recommend is you can export it from Blender as either an STL or an OBJ, and I can do that on here. Let's see. So yeah, if you have anything in Blender, the easiest way to get it into Rhino would be we can export just like if we were in Rhino, and we can export selected. It'll be best to do the same thing in Blender. So we only export like the one thing you're working on. I don't know if you have more things in Blender or not, but if you just go to File and down to Export, we can choose the option for export here. It's kind of up to you what you export as. OBJ might be the
How did you
best one.
do the export selected again?
We just have to make sure the object is selected, so it just has this orange outline.
Okay.
Yeah, and then just go to File, Export, and then choose your export setting. I'd probably recommend OBJ for this. So if you click on that, and then it's going to pull up this window, and this window is where we can, in the top right, press selected object to make sure it's just that one thing. And then that's the only thing you have to do. I mean, the rest would be location, file name, and save that, and we can open it up in Rhino. Okay, so does that all make sense?
Yep.
Okay. Okay, so do you have it in Rhino?
Currently Blender is not.
Oh, okay. Well, we can wait for that to come back. In Yeah, in Grasshopper, I can think of one way to do that, like line pattern that you're thinking about. That might be pretty nice. So let me know when you have it up in Rhino.
There are no objects that fit the STL standard in the file.
What did you export from Blender as?
As STL.
As an STL. And Rhino saying
Yeah.
that error?
I'll try the OBJ.
Okay, sure.
Yeah, I have the thing coming up for the import options. Was there anything specific with the import options?
There shouldn't be, as long as you can see the file, then you should just, yeah, open it and just hit OK. Not coming in. Was there an error or you just can't see it?
Just can't see it.
Okay, it's probably like somewhere else in the scene. What you can do is you can, if you can't see the object, you can come to the top toolbar, to the little magnifying glass icon with the arrows on it, and you can just left click to hit zoom extents. And then it should pull you to wherever the object is.
It's just a bunch of lines.
Interesting. So where is it?
That's the.
Blender. I've never seen that before. We can't have the drop down on the object. Can we try to export again? If we check under geometry, just to make sure that your modifiers are applied to that modifier. Okay, yeah, hit export again on that. Should work. And what if you named it during one?
Yeah, this one was in.
Recording.
It could be that it's really small or really big.
Oh, did it just finish exporting? Or was that loading?
I don't know. I can try again.
Yeah. Yeah, so I think since you have that subdivision modifier pretty high, it's gonna be a big file, but we'll make it work.
Change
Change what?
the like color stuff, so it was no longer.
Well, if you just click off of it, it'll go away. And then you could go, what I usually do is you can go to the drop down next to the perspective. Just on our instead of shaded. Better. Yeah. Okay. Yeah. So with that in, let's put this in real quick. Okay, yeah, so one thing we could do with this is use shortest walk to make a kind of line pattern on it. And I think the easiest way to do that, I brought a mesh and I just have a mesh sphere for this. But what we can do is we could physically set one point in Rhino wherever we want, call it maybe the starting point, and then scatter points on the mesh as our ending points, and then we can make like a line pattern with that. The one thing I would consider before you do it is how many vertices your mesh has. Just because it took a minute to load in, it might be like a lot, and that could really slow down Grasshopper. I mean, one way to fix that would just be to go back to Blender and turn down the subdivision modifier, because you don't need it super high. You shouldn't, at least, but up to you. But I can run through this right now pretty quick. So to start out, you could either populate geometry, which in your sense, I would probably recommend to populate geometry instead of pulling from the vertices that it came in with, just because you probably have a million vertices or something. And populate geometry is going to work for any mesh. It's just going to put points wherever. And then we can use a point component to define our starting point. And with the point component, we can just hit set one point, and then we can physically set it wherever we want in Rhino, so we don't need like a point to already exist for this to work. And then we can drag that wherever just to approximate a starting location. So with both of these, we have the start point and we have the end points that are on the mesh. The only thing the shortest walk needs is it needs to reference the actual mesh edges of the object we have, and the point should align to the vertices as well. So right now, neither of these point groups align to the vertices that are on the mesh itself. So the easiest way to fix that would just be to find the closest point to every point. So in this case, we will have to deconstruct the mesh. So if the mesh is super large, it might take some time. My mesh is pretty small, so it should work pretty quick. And then we want to find the points that are actually on the mesh. Those are the ones we want to search for. And the way the closest point component set up is the cloud, the C is going to be the points that we are searching. So if we want to find those, we can plug that in. And then if we look at P, these are the points to search from, and we know we want to search from these scattered points that we made. So you can plug that in. And we'll do the same for our starting point as well. We want to search from the start point. And now we're finding, again, this is our start point. This is the closest point. So it's actually on the mesh that we can see. Same for the other ones. These are all on the mesh vertices as well, which is good. And then all we'd have to do is define our wanted paths. So the inputs for these are going to be the curve group, and then the wanted paths that we actually want to travel down, which this will be from our starting point, which we found it on the mesh here, to our ending points, all these other ones. And then we can very quickly, I'm going to preview these off. These are all the paths that we want to travel. So say you had your earring and maybe this is the part right next to the head. So you want to start there and branch outwards. You can put that point there, and then all these lines is going to tell it it's going to go that way. So those are going to be our wanted paths. And then we'll just have to define the actual curve group, which this is going to be all of the edges from the mesh. So there's a bunch of different ways to find that if you do mesh edges. I believe this one comes with Grasshopper. The one I'm using comes with a plugin called Ngon. Both do the same thing, but this one gives me all the edges. So I can preview that just with the simple data. So we can see these are all the edges of the mesh. So we can have that as our initial group. And if we plug those in, we can see we start to get this pattern branching out. And then if you want to make it even more random, we don't have to have the paths be straight like this. We can also have them be kind of randomly curved paths. And one way I could think of to do that right now would just be to have a second point group, and we can give this one a different seed, just a very random number to give a different seed, and that will give it a different pattern of points. So with this different pattern of points, instead of using a line, we could use a polyline. So we can actually have a bend to the curve, so it's not just a straight thing, because this is just straight lines going out. And I mean, your mesh is very different than the sphere, so it might look a little more interesting. But this one right now is pretty much just straight lines, which probably isn't the best. So what we could do here is we could define a line going from a start to an end with another stop off in the middle to give kind of a line like that. And that's what the second point group could do. The only thing we'll have to set up is putting these points in the list. So we have 1, 2, and 3 to pipe into the vertices. It's a little bit more than just giving an A and a B value for the line, but it's pretty easy to define. So all we'd have to do is, let's see. So what we could do is we could we could weave these points together. So say right now we have I mean, you don't have to do all this, but just to show. Say right now we have the first list has 0.0, 1, 2, 3, 4, and the second one has the same thing. And if we want to go from the first point in this list to the first point in this list, we want those two to come next to each other. Same thing for the second one, for the third one, and the fourth one. So the way and then we can break it up. So these two are their own group, these two another group, these two another group. If we want to do that, we can weave these two lists together. So we could say, with a pattern, we could just do true, false. And we could put one list in true and the other list in false and say to weave these together, basically go true, false, and make a new list that has 0.0 next to the other 0.0. And by default, I believe, yeah, this weave has a pattern of true, false, or false, true in this case. So it'd be really easy to put these 2 point groups into 0 and 1. That'll weave them all together. So now they're interwoven, just like a piece of fabric, pretty much. And then what we can do is partition the list to actually break this up into groups of 2. So we can put this into list, and we know right now that we'll want, since we have 2 sets, a list of 2 points together will be the best. So if we give it a partition length of 2, now you can see we've taken our list that was just 200 points and broken that up into 100 groups of 2. Each one has 2 points, which gives us a start of creating lines. But if we want to actually start from the original point, we can insert this original point into every single list. So with this, we have the list so that we want to insert to. These all have just 2 points to them. And if we want to insert the original starting point into every single list at the very beginning, we can pipe that starting point into the items to insert. And then if we want to put it at the beginning of every single list, we can insert it at index 0, which will be the starting index of any list. So now this has created new lists that all now have 3 points. So the first point is going to be the original starting point for every single list. And then the second and third are going to be the 2 random lists that we had here. So now if we plug this in, everything is starting here and then branching out kind of wildly. So now that we have this, we can flatten this all down. So we have the same type of line as the one we were using before. Now they're a little bit more random. We plug this in. Let's see. It doesn't like that it's lined, so what we can do is explode this. Explode. Now we should only have lines. So they're all line-like, which is good. Plug that in. And now the curve pattern is a little bit more unique than it was before. And let me change the colors here so we can see this a little bit better. So now it's a little bit more random. And what we can do just to finish this off is, if you don't like the super straight lines, and even so, these are just following what the mesh gave us originally, which might not be the best practice just to use the mesh lines. So we can put some effects on this at the very end to maybe smooth it out. Or rebuild it with more curves. But one thing we could do is change the smoothing iterations on this one. Let's see. And now our pattern is just a lot more smooth. So just some things to think about with patterning it. Another thing you could do is, I know I brought this up last week, but you could use Parakeet for pattern generation as well. There's just a lot of different things here that we probably don't have the time to go over, but I would recommend like exploring all these different patterning things and see what works. I know last class in the recording, we used one of these Venetian patterns on a surface, which is kind of like a mesh vein pattern. A leaf vein pattern. So that's one thing we could do. There's a lot of others as well. So yeah, I'd give that a try and see if that works. And next week we can take a look at it. So, okay. Anyone else have questions? Projects? Yeah. What's up?
So I was on the mesh of consoles,
Mhm.
and I had like a top body and bottom body.
Yeah.
And we're talking about one.
Yep.
So how would that actually feel extended process?
Yeah. So we can take a look at this project from last year. Yeah, so I've got a setup here for designing that. I believe this one needs, let's see, 3 different sub-Ds. So let me just make some surfaces quick. Okay, so this is giving a super simple setup for making those grids, and let's see, turn this on. Okay. So how far did you say you got with like modeling just the geometry? Okay.
I have my 2 values.
Okay, cool. Yeah, so this one's just using 3 surfaces to make the pattern here. I'm doing it with sub-Ds so that we have the ability to kind of edit the geometry of this and make it more shoe-like. Let's see. So maybe something like that. And I mean, this is kind of shoe-like, not really, but it gets the point across. Right here is the setup in Crystalon, and I believe it had an attractor point thing, which we could look at in a second, but it's pretty simple. The first one here is going to be this morph between meshes, which is just going to give us a twisted box, just like if we're using pufferfish, but these are all Crystalon components. So this one just takes your input meshes, and I believe there might be, it's not showing where it is. Like there might be ways to make this with meshes or with surfaces depending, but I think surfaces, like meshes is the easiest way to go because you could do a sub-D, so you can get really any shape you want, and then construct that twisted box pattern. And then right here, you can fill it in with any pattern you want. So the setup for this is pretty simple. We'll have the cell lattice fill, which is going to fill all of the twisted box cells in with some kind of lattice pattern. You just have to pick the cell type. So there is this component that picks the cell type. I'm not exactly sure where it is up in here, but you can use this selector, which I forget if I made this myself or not, but basically, I think it's just giving a number 0 to 14. I just put together this selector so I could see what the names are for them. It looks like actually 0 through 29 is the different patterns you can look at. So right now, I think we're on 0 with primitive cubic, yeah. So let's go up, and then you can see how the different patterns start forming. So you have all these different options with it. And it's, yeah. Yeah, it's a good question. There might be a way to do it. Yeah, I haven't done it in this workflow before.
And for this update,
Yeah.
so these are going to be like 2-dimensional objects.
Which ones are the 2-dimensional?
Like when you made the 3 flat surfaces,
Yes.
can they be 2-dimensional?
Yeah, you can have them like morphing or whatever, but they can't be like thick shapes.
I gotcha.
Yeah. And another thing too, they all have to be the same topology for it to morph correctly. That's why I made one and I duplicated it twice and then started moving it around.
Okay.
If you do like 3 wildly different meshes, it's not going to know how to connect them. So you can still do whatever shape you want for the 3, but they all have to be the same like base topology, but they can be morphed however you want. Yeah. And that'll set that up. But yeah, I mean, there might be ways to like put different cells in different areas. There's a lot of tools here, and we're only looking at like three of them. Let me see, I think.
Is there a certain number of layers you recommend? Like, is it need to be a minimum of 3?
I mean, the minimum is 2. You can do however many you want. Basically, what the services are controlling is how many like rows you have in this pattern. So right now, like we have 1, 2, 3, 4, maybe like layers of height to this. If I only did 2 surfaces, like if I took this one out, okay, actually, never mind, that changed nothing. So the number is going to be in the slider. So I guess it really doesn't matter. But if you want to have more interesting curvature through the piece, you could do more. Really up to you. This one here, voxel morph attractor. So I'm going to plug this in and see what it does. But I think you had a question last week too of like, can you change the scale of it based off of point?
Yeah, more so, I guess, just altering like how dense the pattern is in certain areas versus others, or if it tends to be.
Yeah. I mean, this one is definitely affecting something. What level it's affecting it to, I'm not too sure. Okay, so, I mean, so that's like kind of shrinking it down right there. Yeah, very interesting. But yeah, I mean, there's a bunch under modify that you could play with. Where did I get? Or yeah, so morph value, morph attractor, and a bunch of other stuff. Actually, I think this one right here is going to be okay. That's what. So the selector does come with it, which is good. Oh yeah, I mean, there's a bunch in here. I mean, I just go through and see what they all do because I believe like everything in Voxelize is going to give you a V value, which you can use to go into the lattice fill. So I'm just looking at one of them, but it looks like there's like 20 here. You could try them all out. Yeah, it is affecting something.
Is there any way we can think of that call?
Yeah, I can definitely send it to you. I mean, I could send you this one. It's pretty messy at the moment, but
Yeah, that's fine.
yeah. Yeah, let me put it in file sharing here. Okay. So yeah, I'm not sending the sub Ds along with it, but
Yeah, that's fine.
like you can just populate those with whatever you have. Cool. Okay, awesome. Anyone else have questions?
I've got a question.
Yeah. You have a question?
Okay.
Yeah, Camden, what do you got?
So I'm still waiting on my like teeth impressions to come. I'm working on that too. Stuff I've talked to you about. I just have like a troubleshooting. I kind of can't figure something out. But can I share my screen or?
Yeah, you definitely could.
Let me share both screens.
Okay, so what are you looking at, Camden?
So I made this in SolidWorks yesterday.
Oh, nice.
Kind of giving up on the radial patterns because I can't get the hole small enough to make it look right. So I'm trying to make this but controllable with Grasshopper.
Yeah.
And I'm struggling. I've got it to work where it scales based on the distance from the center line, but then I want them to move closer based on that distance, and it's starting to like moving them all up high, and then some are like scattered around here. I downloaded that plugin for the graph controller you sent me. But yeah, I don't really understand why they're all like focusing up here. Is there a way to just have them move in one direction as opposed to moving?
I mean, yes, I'm just not too sure without like looking through the grasshopper myself.
Okay.
What could be causing it? Yeah, I mean, if you want to like share the Rhino and Grasshopper in the Discord, I
Okay.
think it might be, yeah, more efficient to take a look at like what could be causing that problem on my side.
Okay. Yeah, I'll just save it and send it in file sharing.
Okay. Cool. Yeah, we can do that. Yeah, so on, let me look here. I'll share my screen again. Yeah, so you got the tube.
Yeah.
And what else are you trying to do with it?
That's what I'm asking. I don't really know what to do next after I have my shape around person.
Yeah, I mean, yours is mainly like material study, yeah, with
Basically,
the flexible
yeah.
printing. I mean, I'm curious, do you think you could do like a scale model of this that would just fit on the bed in one print? Just to test like the inflation side of things.
Yeah, I guess.
So I think that's kind of fun. Or I mean, you could just do like a pillow shape or something. But it'd be fun to test the inflation and see if that works.
I guess that's my question. Or I guess setting up the STL to be able to print that way. Would that be fine us with the STL in the lab and we could do it in this course so that we can be included? Or would my STL have to have like some sort of like inner tube running through so that like
yeah, I mean, I think printing it is going to be more telling of how it works. Like you could simulate it with Kangaroo if you wanted to visualize some kind of inflation. And we could look at that if you want, but I think like actually hooking it up to a compressor and trying to inflate some TPU would be more interesting.
Sure.
We have a compressor in the robotics lab, just like across the way. So, and that just has like a standard compressor fitting on it. I don't know like what size that is, but I don't think you need an inner tube. I mean, let's look it up quick and see if we can find. Because I did see like a study on this before.
Tremendous helps you send.
Yeah, I hate that. Does anyone know if YouTube still hates ad block? Or okay. Your ad block works? You just have like ad block, the ad block?
I mean, I have one where it like fast forwards the ad.
Interesting. Okay.
Like, totally blocks it, so it's technically not.
Interesting. Okay, yeah, so I've seen the shoe one before, and I think all they're doing, I mean, you can see the cross section down there, where it's just a hollow shell. They're putting tethers on it, just like stringing a bridge across the inside, so it doesn't like actually inflate like a balloon, which I don't think is necessary for what you're doing.
Yeah, I mean, they're doing it agree that because the person's wearing that support lines more.
Right.
Literal.
Yeah. So it looks like you can just get away with doing a print without infill, and that would give it an internal volume. Looks like they're pumping out with a bike pump. So however you manage to do that fitting.
So I guess it would be like I have my form.
Mhm.
I get a grasshopper that would do maybe it's better just make it like a regular STL thing and then have a insertion point like a bike pump.
Yeah, I mean, you could export it as an STL from Grasshopper if you like that form. Yeah, and I don't know how the fitting would work. Maybe you can just poke a hole in it that's the right size and then like hold it in. Or if you want to somehow thread an actual like brass fitting into it,
Yeah.
I mean, you can make the hole smaller and then get a thread
Right.
if that's airtight enough, and it should work. I mean, this looks pretty good, so I'm very surprised they didn't have any leaks with it. Like they're printing it on an Ender. So not the highest quality of printer, but it seems to work. Yeah.
We have one vendor that works in the lab right now.
Wait, out of the red ones? They're like an actual, oh, yeah.
All the other printers are booked for 3 to 7 days. With one print each. Anyways, back to my
Yeah, so
question.
you know this should inflate fine. I don't actually know how many walls they're doing, but I would just start with 2 walls. Yeah, they don't specify, and just see if that's airtight enough. So
Do you care what slicer I do with it on my laptop and then bring it to the lab and put it on my bed?
yeah, it shouldn't matter.
Okay.
Yeah, do whatever. Is the Idea Maker doing flexible yet?
We haven't had a chance to because
Yeah.
the back right one that had the right nozzle looking only is now jammed, so that printer's not currently out of order.
Was the bed leveled?
The bed, I don't think it's level.
Okay.
I don't think there's that chance to get it.
That's fine, because I think it just jammed because the bed was not level, so the nozzle was,
Right.
it couldn't,
Yes.
so it got clogged that way. But that's easy to fix. It's just leveling is more
Okay.
important. Yeah.
Actually, I don't know, did you fix that actually?
Mm,
When you came in there the other time?
I fixed the
and-
clog once.
Yeah.
I just moved it away, ran PLA through. It was fine.
Yeah, because I tried printing off his soul the
Mm-hmm.
next morning and it came out like white and clear. I've never remembered that from last week.
Yeah, white and clear is weird because it's black TPU, so I don't know why it's doing that.
Yeah, it was definitely interesting. So,
Okay.
that printer's down. The other one that's been down is still down. And then there's the one girl who's printing her 3D print, which should be done tomorrow. And then there's Diane's print some. And then the one that's currently on the 5D print.
Okay.
And the other 2.
Interesting. Maybe I'll take a look after class.
Yeah.
Okay. Cool. Camden, were you able to get those models in file sharing? Okay, I do see them.
Yeah, it's just the grasshopper one.
Okay, I'll download that real quick. Let's. Okay, so let's take a look at this. Okay, so you're trying to move them about this line, yes, but they're all just moving in a single direction.
Well, I was just putting in the line to like kind of visualize and make sure my closest points weren't, because it looks like they're all moving up towards like the top point. These lines I just put into like you had showed earlier, just to kind of see if all the closest points were working.
Yeah.
But yeah, I would like them to move like just in one direct, like just in the X direction towards that center line.
Right. Yeah, so I mean, it looks like something is not lining up because you have more movement vectors than you have points. Just because we can see this top one, it's moving this one point to all these other spots, which is curious. So we have 301 and 893 here. So I do wonder, what does this have? This is 893. I think maybe if we move these points instead of the attractor points, then those are going out. So yeah, can it look like what you're doing was moving the attractor points themselves? Which I believe you'd want to move the actual points controlling the pattern, yes?
Yes.
Okay, yeah, so that was just a simple switch of put these points in the move.
Okay.
And then that vector display looks, let's see, looks a lot better.
And then in that remap to implement the graph thing, where would I?
Yes, so with this one, we can kind of bypass the remap graph second remap because this you can put in the source and the target.
Yep.
Which now that we have that option, we can use the bounds and the length and then just give it its final domain, which I believe is this one. Give it Bezier and then just pipe that into the amplitude. So that allows us to skip, I did too much, to skip this. Okay, so this is what it was by default. And then, I mean, you could scrunch it up like this, and then it looks like, what should we move? And then like, is something like that what you're looking for, Camden?
Yeah, kind of like a 2D curve, like a
Yeah,
fall
okay.
off on the edges.
Yeah.
I needed to have them move in because to get like the length on the slots that I wanted, I had to increase the grid way larger than my like the size of the template I'm cutting, if that makes sense.
Gotcha. Yeah.
Because I want like longer, like 1 inch long slots, which this isn't set up for right now either. But once I like, because I'm basing getting like the brick pattern from a hex grid and then putting a rectangle in the center to get those offsetting lines.
Yeah, that all makes sense. Yeah. pretty good.
I guess could I switch that out and use like a diamond grid, and then I would have more control over the width? Because the hex grid scales uniformly.
Possibly. Are you talking about like?
Because I mean, wouldn't they fall the same if you use like a diamond shaped grid? Like you would still get that like brick laying pattern.
Yeah, because I mean, a triangle's just gonna like split up the hexagon a little bit more.
But no, it's I used one earlier. It's like a square grid flipped sideways.
Interesting.
Like a die. Let me see if I can find it.
That one's on me still.
I think if you just type in grid, it pops up.
Like one of these or?
Yeah, diamond grid.
Oh, interesting. Where's this from? I see. Okay.
I think that's right. Let me open up Grasshopper. I mean, I can probably mess with this and figure it out, but I think that would allow you to scale like more left to right, because the hexagon grid doesn't really give you like different scaling.
Yeah, interesting. I haven't used this diamond grid before, but I mean, yeah, it's doing something. Yeah, you could definitely play with it. I think like now all this should work. So the scaling is working correctly, and then I mean, yeah, you can put in whatever grid you
Just
want.
change the grids out.
Yeah, yeah.
Yeah, I mean that's working much better than, or yeah. Yeah, so I was moving the attractor points and not the grid.
Yeah, yeah. All I did was you had this one from the line plugged into the move. I just switched it out for the actual points from the hexagonal grid.
Okay.
The move is looking pretty good. I just added this vector display to check the vectors. So now we can see like an arrow pointing in which way it's going. And then, yeah, just cleaned up the clutter of what we were doing yesterday just with this new graph mapper. So a lot cleaner.
Okay, and then I could also put that new graph mapper down in the bottom.
Yeah, you could do the same thing.
Yeah.
So you could have this replace all of this. Yeah.
Yeah. All right.
Cool.
Cool.
Yeah, pop this back in here. Awesome.
Thank you.
Hey, you're welcome. Okay. Anyone else have any questions? Katie, how's your mouse coming?
Pretty good. There's
Yeah.
just a lot of curves. So.
Nice. Well, that's a good thing. I mean,
Yeah.
you need a lot of curves. Let's see. Jenna, are you on the call? How's your bag coming?
Hi, yeah, I'm gonna be completely honest with you. I have not had very much time to work on it, but that's what
No
I'm hoping
worries.
to continue doing today.
Okay, sounds
Yeah.
cool. Sounds cool. Isabella, are you in here? How's your headdress coming?
Yeah, I got pretty much the shape of it down, like with a couple of loft curves
Nice.
and like doing the surfaces. And then I managed to get like a bit of a diamond mesh, but definitely what you were showing I'm definitely trying to improve that after what you showed with the first one, the like headdress one. That helped a lot. But yeah.
Nice, nice. Sounds good. Cool. What else we got? We've got two Bens in here. I don't know who is who, but how's y'all stuff coming?
Mine's okay. I'm the top hat one.
Yeah.
I mean it's going well. I don't really have any questions at this moment.
Yeah,
I'm kind of
sounds
just
good.
playing around a little bit, but sure. Once it gets a
Okay.
little bit closer,
For
I'll
sure.
figure it out.
Sounds good.
And I'm the other Ben. I was actually thinking of changing my project.
Yeah.
This is something I want to play with, like the flexible PLA. Like it's for like just something really simple, like I don't know, like a poncho or something. But I don't know how much material that would even take to make something so big.
Yeah. I mean that kind of goes back to, let's see, what we were talking about with Leah's project. 'Cause I know, yeah, this person has made like pretty big flexible things in the past.
Yeah.
So, I mean, if you think about it like just a traditional soft goods project, like printing garments, then it really wouldn't take that much filament to print flat pieces and put them
Okay.
together. Like, yeah, this coat jacket was I doubt this was a lot of filament because it's all pretty flat.
Okay.
Yeah, so you could definitely try something like that, and then it's really like what are the pattern shapes that you're wanting to print? Like that's the main question there.
Yep.
Also, I mean, this is a interesting point just in the video where she's using a 3D printing pen to weld the pieces together instead of sewing them. So for you and Leah, that might be interesting. We do have some 3D printer pens that you can rent from the architecture library and
Okay.
run TPU through it, or you can sew it together traditionally. Both would work. Yeah.
Got it.
I mean, is that helpful for like doing what you're thinking about?
Yeah, I haven't like decided on any types of geometry yet. I think my biggest question was, is it feasible? Like in terms of material, or is it like too expensive, basically? But yeah, it sounds like I can pull something
To
together.
do a whole poncho? Yeah, I mean, I'd say it's really up to what design you come up with. And I guess if there's some reason that 3D printing it will be more interesting than doing it out of just normal fabric,
Yeah.
then that would be like the main argument for why you would want to do this with TPU. Like, is there geometry that you just can't do with normal fabrics, like 3D pieces or something, or like the way it's
Yeah.
printed and you're putting it together. Just maybe like a justification of why you would use this over normal fabric, just to give it another boost in like the reason behind the project would be cool to see. So
Okay.
yeah.
Yep.
Nice. Fun. Let's see. John, are you still working on the 4D pattern stuff?
I was having trouble downloading that.
Yeah.
I think I followed the process correct because I did the same thing for the Tundra and Word, but it just keeps saying that it's not supported in the file. For the 4D one.
Like the 4D noise that wasn't working?
I also got the preview work, for example.
Yeah, the example files.
Yeah.
Okay. Let me see. Yeah, I've never personally tried 4D noise. I have tried Tundra, and you can do stuff with it. But let me see if I can find. I mean, well, before I do that, I guess it's up to you. Which pattern are you more interested in going for?
Initially the sound.
Like this one?
But the main reason for that was I thought it'd be easier to pass. So I might.
Right. With the right one? Yeah, I mean, I think like casting would be very similar for both. But yeah, since you want to try the right one, let me find that file. Just give me a minute here, try to look for it.
So how would you suggest like going about making the actual like, I guess surface? I mean like to make sure that it's like the right fit around the actual surface.
Yeah, I mean, I'd say either you could do a 3D scan of the foot, or you could find just a 3D model online, and then all you'd have to do is like maybe what I like to do when trying to make it real life is to measure two very obvious points. So if you're doing like a full body, I'd do like head to feet and like scale based on that. If you're doing a foot, maybe you could do like toe to heel. If that's like, I don't know, 11 inches or whatever, then you can just do that in Rhino and scale it so the same 2 points measure up to whatever distance it is, and then work with that. That's the easiest thing. Okay, we'll wait for the grasshopper to come back because I'm hoping I can just give you this file for this other kind of pattern, because we didn't get to talk about it last week, and we'll see if that works. While we wait, did anyone have any other questions for me today? You have a question like in grasshopper specifically, or
not.
Well, you can go because I'm just waiting for this to come back. I have no idea how long it's going to take. So if you want to. Oh, so it's this file. Okay, so this is kind of the reaction diffusion one that is going on. There's a lot in this file, but okay. Yeah, we'll come, you put it in homework. Okay, yeah, we'll open that in a second, Christian. Yeah, in this one, this is doing like the reaction diffusion pattern, so you could apply this to any mesh you want. I'm curious. That's in that one, okay. It's more complex than what you would need because I'm doing a lot of other things here. But the main chunk of it is just going to be these C# scripts. So someone wrote the code to do it, but yeah, I'll see if I can export just like a basic version of this where it just has like an input output that you can play with maybe tonight or over the next week. Yeah, but if you're interested in that design, I think we could definitely go with this and try to figure that out. So, okay, I'll come back to that. Okay, so yeah, do you want to explain?
Yeah, so essentially the idea behind it is that it's a sort of harness that you put on, and and with like runners in particular, like X bikes or marathon racing shoes.
Yeah.
If there's a pair of shoes that you're wearing versus ones that you want to wear to your destination, it's kind of a hassle to like hold it in a bag and then
Sure. Yeah.
so the harness was able to like sort of hold it behind you. So it's just
Oh, I see. Okay.
it wouldn't necessarily look like that. It would kind of fit more.
So you can wear the harness itself.
Yeah.
Yeah. Okay. I like that. That's cool. Yeah. That'd be a good first step to get a 3D scan, and then you could probably. What Rhino do you have, by the way? 7. So yeah, you could use the sub-D tools with your scan. So just import the scan and start like mapping out a surface, kind of over your shoulders on your back of what shape you think would look good. And you can probably build most of it with sub-D stuff. Like, are you imagining this would be a kind of bungee elastic cord holding it in, or?
Yeah, I think there would be like some sort of like there's like the base of it that's actually like on your body, and then some sort of other things material that would be on.
Okay. Yeah. I mean, I really like the idea. I think starting with a scan and a base form would be pretty good, and we can come back to it next week and talk about like the next steps. So.
And then, as far as materiality goes, what would you suggest, since we're talking about designing it for specs, having some sort of material that would be efficient?
Yeah, I mean, like you could definitely do something soft, like have a TPU piece, which would be like a soft 3D print, or we could even like inlay it into a more solid shell on the back if you want to have like a section that you then like you print most of it as a solid shell and then have a place to put a TPU like soft thing. Yeah, you could definitely do that, and maybe just leave space when you're modeling with sub-Ds to do that. Yeah, and I remember I shared a lot of videos during the beginning of the semester for modeling with sub-Ds. That might give you some tips of like how to like make a hole within a sub-D or like bridge pieces of sub-D together to kind of get that cavity. Because you might be going into sub-D modeling a lot more than some other people are if they're just doing like base forms. You'd actually want to get this pretty nice. So you can maybe, I think those are in the recordings, so I'm gonna watch those. But yeah, no, it sounds pretty good. Yeah, I definitely start with what you're thinking. I think you have a pretty good plan. So yeah. Also, yeah, Joe, I'll see you. Okay, any other questions? Either here or on Zoom. Okay, well, if not, we have 4 classes left, I believe, so we'll keep working on the final project in class. We'll probably look at rendering, digital rendering, near the end once you guys have models together. But other than that, I'll see y'all next week. So, yeah. Cass, how's first year going?
Good.
Yeah.
We're working at RDF right now.
Oh.
Which is kind of exciting.
Are y'all doing the big wire cutting, like foam towers, or?
No, we did a House of Clay competition earlier this year, and
yeah.
I think we're doing it into Shackathon too.
Okay.
I don't really know, so we're just building it now.
Nice. Awesome. Yeah, that's cool. Yeah, I saw Chris was doing some Shackathon stuff.
You know, our house is so cool.
Yeah, very, very interesting.
Yeah, it's a lot. Yours.
Okay, yeah, see you next week.
RJ, I'm setting up the slice right now. Can you look and see
Yeah,
if
yeah.
I have the right positioning for it? Whoever's printing says that. I don't know. I'm near.
Yeah.
That was near. He did he taught the. So I have a set of one of those like this right now. I have set up like this right now. But yeah, it's just for, I don't know if it should be placed this way, or should I should place it on, I guess, its feet, not standing up.
I would take rubber print.
Okay.
If it was all of, it's pretty flexible on the
Yeah.
or on the end.
I haven't tried it on the ender yet, but I'm willing to try it.
Just because it's.
Yeah, this is just my slicer that I have in my laptop.
Oh, yeah. I like it.
Cool.
Yeah. I don't know what Henry has set up for like the support Z offset. For CPU. That's the one thing.
He has his own like filter on it in the IDEA Maker slicer.
Yeah, the CPU like it supports UV bonds with all the pins.
Yeah.
Up the offset a little bit.
Okay.
But if anything, it's cool.
Yeah, I'll ask him about it too. Cool. Thank you.
And you're just gonna do no infill?
Yeah.
Okay. That works.
I did it freshman year actually, for the NAEP toy competition, and no infill print. It was like an infinity ring. And it was clear, and I opened it up, put like little beads in it, and then sealed it back together and made like a little fidget toy.
That's fun.
I'm surprised that it worked, to be perfectly honest with you.
Yeah. That's interesting, because we had a massive one like that in the I don't know if you've seen it. So it was like that purple.
Oh.
Only half of it, I think.
Yeah. But I probably no bigger than like that.
Gotcha. Yeah, that's fun. Did they still want you to use wood for that? They're a wood company.
I really didn't know what I was doing for that competition. Mira didn't give us any guidance. I had also like just switched into IB at that point. And I was architecture in the fall that year, and he was like, no, you're not required to do the competition if you don't want to. And it was just me and Elon, who are the IB kids, and Elon didn't want to do it. So he was, you know what, why don't I? And I tried something, and I 3D printed it.
Okay,
So,
that's fun. I mean, I kind of do everything zero infill at this point. I just do lightning infill. So it only like does it where it needs it.
Okay, yeah, I'll give it a shot too. See how that works out, because I think it might need some internal support just for somebody wearing it, but I'll see.
Yeah, good luck. Real quick.
Yeah, so if I have a mesh with 19 faces inside the shelf, but the rest of it's perfectly fine, is that good enough to 3D print? I've managed to rip the object, and I've been trying to get it, so and then I just need to do these eye slits, which I got on the description.
Yeah.
But like, I basically just use Grasshopper right now to like code the inside of the helmet, because there's no actual inside, so I was like, I need my head to go into something, so I did that.
Nice.
And then the goal is just, I'm gonna make both a mesh and an object version of this, and then it's gonna be the coding of how to actually do what I was talking about last week.
Yeah, those little.
Yeah, I didn't make too much progress, but I just want to show that like
No,
I
cool.
got the base of it ready already at least. So.
Yeah, I don't think like, I mean, it's pretty much up to Cura, like the slicer software, of if it's gonna have problems with not printing. But usually they're pretty good nowadays that it can fix tiny issues. Like
Yeah, because I was able to fix a couple like little holes in it, but like a couple of the mesh faces, I don't know enough to like repair it properly.
Yeah. Okay.
I think the slicer should take care of it, and if not, there's other software we have that we can just run it through.
Okay.
Make it better.
Yeah, but I just, so
Yeah.
you got the object running.
Okay, no, awesome, looks good. So you're on.